Okay, so after getting familiar with the concepts of mutual exclusiveness and independence, okay, let's start on this question. So we have a product, and before launching it, okay, we have to perform a test. The test has two parts, part A and part B. The product can be launched only if it passes both parts of the test. Okay, so but we have to assume that the two parts are independent of each other. Okay, and it's given that the probability for the product to pass part A is 0.95 and the probability of passing part B is 0.88. Part A, find the probability for a randomly selected product to be launched. Okay, so for it to be launched, meaning what? Meaning that it has to pass both tests, right? And it's an intersection, right? So the key part is to be able to recognize it's an intersection. Okay, it passes both A and B, and because they are independent of each other, then we can make use of the formula that it equals to the product of the individual probabilities. Okay, remember, if they're not independent, then you cannot do that, right? And that equals to 0.836. So part B, now we have three products, okay, to be tested. Okay, find the probability that at least one of them cannot be launched. So it's another level, right? So this probability, at least, meaning there are a few cases, okay? One product cannot be launched, two products cannot be launched, or all three cannot be launched, okay? So in order to save time, we could use the complementary law, right? So that equals to 1 minus the probability that no product can be launched, okay? And for this second part, you could consider it as three different processes, right? Okay. And what do we do with processes? We multiply them together, right? And so it also equals to 1 minus the product of all products. All three products can be launched, and it's a product of three numbers multiplied together. And so that equals to 1 minus 0.836 cubed. And so the answer would be 0.416.